Hello, my name is Jean-François Fortin. Today I would like to introduce you to the Olympus BIS. BIS stands for Bar Inspection System. These systems are designed for round and square bar inspection using phased array technology. Different types of material can be inspected, such as carbon steel, stainless steel, and special steel. The BIS is available in 3 models: BIS T1, BIS T2, and BIS T4. The BIS T1 can inspect round bars with diameters ranging from 10 to 65 millimeters. The BIS T2 can inspect round or square bars with diameters ranging from 20 to 120 millimeters. The BIS T4 can inspect round or square bars with diameters ranging from 50 to 254 millimeters. The BIS can be set up according to the required inspection configuration in the QuickView software. This includes the longitudinal wave for volume inspection and the shear wave for subsurface inspection. Due to the flexibility of the phased array technology, configuration and inspection modes are typically changed by software with minimal intervention required on the inspection head. The BIS comes with a fully automated calibrator for equalization of the phased array probe. Olympus can supply the BIS as a fully integrated turnkey solution. Behind us, we have such a system, more specifically a BIS T2. Throughout this video, we will use this system to demonstrate the general concepts applicable to all BIS models. This is the inspection head of the BIS. More specifically, we can find here the immersion tank. Inside the immersion tank, we have the floating UT head. And on top of the head, we find the heart of the system, the quick-scan-LT acquisition units. More electronics can be installed on the system to either improve its productivity or its detection capability. Below the quick-scan-LT acquisition units, we find the floating head containing the phased array probes. The design of the Olympus floating head and immersion tank ensure optimal water coupling conditions. On each side of the immersion tank are the floodgates. The floodgates are designed to retain the water inside the immersion tank, limiting the need for water refilling and avoiding water disturbance. The water brought to the immersion tank is carefully handled through an advanced water management system to eliminate all bubbles. We have removed the floating head from the immersion tank to have a look at what is hidden inside the Olympus BIS. Here we have the centering devices. They are used to ensure that the probes are in the optimum position in relation to the bar. This exclusive concept provides a constant dynamic adjustment of the probe's position to keep them perfectly perpendicular and concentric in relation to the bar surface, despite bar straightness variations. The Olympus floating head concept ensures high dynamic detection repeatability during the inline inspection of production bars. The floating head holds the probe holders or cassettes on which the phased array probes are fixed. In the case of the T2 system, the floating head contains 3 cassettes holding a total of 12 probes. 6 probes for the first half of the range and 6 for the second half. The 6 probes are arranged throughout the cassettes in such a way as to ensure full volume coverage. The BIS inspection head is designed for modular integration and easy maintenance. All components can be easily accessed for regular inspection and maintenance operations. The phased array probes are very easy to connect to the quick-scan-LT acquisition units. The easy latch connectors are spring-loaded to ensure a good connectivity and cancel the effects of vibration. A complete changeover process between product ranges is fairly short due to the design of the BIS. Depending on the BIS model, the changeover process includes changing the phased array probes by switching cassettes, connecting the right probes to the quick-scan-LT acquisition units, and loading the correct inspection setup. All of these steps can be achieved directly at the inspection head, which helps to reduce downtime. Once the head has been set up, we can move on to the equalization of the phased array probes. The equalization process for the BIS is very simple and performed by a fully automatic calibrator unit. This ensures better and more consistent results than manual equalization. The calibrator unit is made up of a calibration bar with known reference defects, along with a motion system that precisely moves and rotates the calibration bar so that every probe sees the same reference defects. The calibrator is controlled from the operator station, and the equalization results are managed by the QuickView software. Typically, all the probes are being equalized on the same two defects, one for a longitudinal wave and one for shear wave. In QuickView, we can see the signal response of every aperture on the phased array probes as the calibration bar goes through the system. The goal of the equalization is to bring the response of every aperture to a specific target level, typically 80% plus or minus 10%. After the first pass, some apertures may not have reached the target level. Actual equalization is performed by selecting in QuickView either all of the apertures or only those that did not reach the target level. After the selection is done, QuickView will automatically apply the required gains to reach the target level. Now, as you can see, after the second pass, the equalization is perfect. Now that the equalization process has been completed, we are ready to inspect some bars. But first, we must bring the inspection head to the online position. With the inspection head in position, we can start the inspection from the HMI. During the inspection process, data files are generated for every inspected bar and saved on the acquisition PC. All inspection information, including alarms and defect positions, are automatically recorded in a database for future reference and traceability. This concludes our introduction to the Olympus BIS. For more information on Olympus bar or tube inspection systems, please contact your local representative or visit our website at www.olympus-ims.com.